Okay, hi everyone. We are continuing our long-running discussion of multi-computation, and we are looking at lazy functions again today. So, Nick, the lazy wrapper.
Yeah, so this one, it's very early prototype. It's a dynamic version of a wrapper. So it basically treats every function that may produce a lazy list or have a sub-value that works with lazy lists kind of work.
So wait a minute. So what is this doing now? So this is, why is there that normal? I'm totally confused by what to
Well,
name.
normal can be inside or outside. But the point is that without normal, it would produce a lazy list object. But if you run normal...
Sorry. I was just gonna say, I assume this is basically just doing replace all and replacing things like take and selector, or at least replacing range with the lazy range.
It's a little bit trickier than that right now. It's dynamically overrides some of the functions that should produce a lazy list, like range and array. As soon as you run range inside of this lazy wrapper, it will run a lazy range version of it.
Okay.
So, well, if it does it dynamically,
yeah.
So if you call the function, if you map the function f over your range, and that function f called range itself, that function f has a good chance of breaking, right?
Yes, that's the problem with it, right?
Right.
Okay, so hold on. So what you're saying is, this is a wrapper. This is the generic case of that wrapper, right?
Yeah.
And so now if I say something like take that, comma 5, okay, and now I say normal of that.
I see. So all this is doing is it's not take and so on and select all already have the values.
Well, Christopher, your internet seems like it's your audio seems to be at the end of yeah.
Hold
on.
Yeah, basically all the functions that work with lists have a sub-value for lazy lists. And functions that should produce a lazy list would work inside this lazy wrapper. And I guess because it can break stuff, there should be an additional wrapper, like unlazy, if you want to stop this behavior inside.
I'm confused. This is not...
Or to be lexically scoped.
Okay, let me try to understand. I mean, originally we had the plain data type of lazy list with a range of constructors like lazy range, lazy table, lazy nest list, and so on. And then there was the question of whether we should have a simpler way to represent those constructors. And something I've done for iterators is have a wrapper that, so you can say lazy of range of, which would then produce, call the lazy range.
You're saying so this thing here.
Yes, and so this seems to be exactly that proposal. Originally we then dismissed this because one problem is that yes, but I mean wrapped around the whole thing, lazy of range of infinity.
No, that's different. That's a different thing.
Yes, but I mean
that's one. And then there's this. Oops. All right.
Lazy of range of infinity. Yes, I mean, and we dismissed that because the syntax of the components was different, and you really didn't know for which arguments lazy would actually work. So I think having explicit constructors for the plain data type of lazy list is better. Now, last time we had these lazy values, which I think nobody really understood. And so I then asked the question what the difference was between these lazy values and just lazy of anything. And I mean, this proposal just treats lazy as a wrapper that turns everything back into the good old lazy lists. And the lazy list is a very useful data type. But I kind of wondered, but this is not something we can just write code about, whether there's more we can do with keeping anything lazy and deferring its evaluation. I mean, this is a very not well thought out thing, and I'm not even sure we can come up with a specific semantics for it. But at the moment, it looks to be just like a wrapper for the good old lazy list.
I'm really confused by this. I'm sorry. I'm just confused. I don't understand why. I mean,
So it seems like
go ahead.
I'm Nick. Correct me if I'm wrong, but it seems like sort of the purpose of this is if you have code, if you have code that you wrote without thinking about laziness, and maybe it's really slow because it has to generate, a list of some giant output or something, and you want to basically say, make this whole thing lazy, so I get a lazy list as my output. That is that
Right.
kind of
Yeah,
the use
that's
case
the
for this?
Yeah, that's the idea. Yeah.
Okay,
I mean,
so it's for, but now if you were just writing code sort of, fresh, and you knew you were going to need laziness from the start, you wouldn't want to use this interface, would you? I mean, there are other ways you could use lazy range or something like that to create the initial range.
Sure, you can. It depends how broad you want to apply this kind of wrapper. You can apply it just around your ranges, and that's it. But you can also apply it on a larger code.
I mean, this reminds me a lot about the discussion about parallelize, which seems to be a good idea, but in practice, you have to know for which functions it even works, right? If you have lazy of something where there is nothing lazy inside, lazyable inside, then what do you do?
Right. I worry. Yeah, exactly. I mean, I worry it's just going to be kind of a mysterious thing when in this case, it's really pretty straightforward to make it explicit.
Okay. How would you make it explicit? And by the way, where are the notes from last time? Because we need to make sure we don't go backwards in these meetings. Where are the notes?
They are at the end of the agenda. Additional resources.
Actually,
yes.
it's right on the right hand side, right? I mean, these constructors were really the most important thing. You know exactly which things you can turn into lazy lists.
Okay, so explain those constructors. You mean these?
No, sorry, no, not these. There was another list of
lazy
here. Range. Yes, this list.
Right.
Yes, the top one. Yes, the generators.
Mm-hmm.
Okay.
Right. So I think maybe this was 2 times ago or something. There was some objection to having lots of functions, but the lots of functions that were I think objectionable were the functions that had no analogs. These ones all have analogs, right? And hopefully they take the same arguments basically as their.
Well, not basically. Do they take the same arguments, except for the fact that they can have infinite cases here?
Yeah, they should. It depends on the implementation whether it supports.
No, I understand, but I'm asking specifically the ones that you've implemented. Do they take the same arguments?
Yeah.
Okay.
And so, well, sometimes they also take the functions that take lists. There's a version that takes lazy list, for example.
Okay.
Like you can take maybe tuples of a lazy list.
Okay. Okay, but so, I mean, we don't really like the prefix lazy, but let's go with that for now. So what this is doing is it is somehow managing to transform this. There is no lazy take. So this is take operating on a lazy list, right? There is no lazy select.
Mm-hmm.
The only thing that is generating, so as I understand it, the equivalent form to this would be, if I say here, if I forget about this part, do this, and I say lazy range of infinity. What happened here? Oh, there we go. It's probably loading something. Okay.
And you could say normal of that, but yeah.
Yeah.
Well, can I say no? Okay, I can say normal of that because it's finite.
Yeah. Yeah, because you did take 10.
Okay. This seems pretty good to me. So now if I were to do something here, instead of select, I would say cases here.
I don't think I have cases. Support.
Cases.
But this is where we're falling off the train again, right?
Well, I think cases harder
I
harder
understand
case.
it's harder.
But
I understand it's
Yeah,
harder.
fine.
But I'm trying to understand
Well, case
how
is
this is going to
exactly
be
the same
actually
as
usable.
select, right?
Well, actually, the big problem with cases is the fact that cases takes arbitrary expressions. Right. So select maybe takes somewhat arbitrary expressions, but like cases, it's normal to give cases some weird symbolic mess.
And it has a
Yes.
level, right? Because it has a level. It's not just lazy list.
Right. The other
Okay.
feature is actually arguably that this is unfortunate, but actually this is maybe not unfortunate. Okay, there should be a lazy cases, because the thing we did, for example, with associations is that cases takes whatever structure and returns a list. It doesn't return that other structure back like select does. So arguably there should be a lazy cases, which would have some use because it would basically use the lazy pattern matcher.
Yeah, and also works on a lazy structure.
Yeah, so we are just propagating an old design mistake, right?
Which old design mistake?
Well, the cases and select don't return the same head.
I'm not sure.
I'm not sure it is a design mistake. I think it's an unfortunate design requirement because think about it. Like if I have some crazy XML element, blah blah blah, crazy symbolic thing and I run cases on it, it has to return a list, right?
Yeah, whereas select has
the
to return.
problem.
It's not a design mistake, but okay. But so then, what we've got. So what Nick has implemented here is this generic lazy wrapper, which I think we all think, parallelize being the example. It's going to be like if I put cases in here, it'll fail in some totally random way, basically here. If I do this and I lazify that, what's it going to do?
Can you try position instead of cases? At least position is implemented.
No, I'm trying to type something that isn't implemented because there's 7,000 functions and most of them won't be implemented.
Yeah, so the requirement for lazy to work is that somewhere inside there is a constructor which returns a lazy thing, and everything around it needs to know how to handle it.
Yeah. Well,
Look, this is very reminiscent of the compiler and types and all this kind of thing because lazy range does just fine. We're great at that point, but as we go outward from that, it's turning into garbage. I mean, but also to be clear, I could say something like, let's try this. Okay. See, I'm about to tangle this up horribly. Let's say I say transpose, range infinity, range infinity.
That actually might work. But
Well, let's find out.
Try.
I had asked somebody to change my machine so that it changes this color, and I'm going to do this right now because I'm trying to experiment with, because I'm fed up with this incomprehensible. When is it green? When is it not green? Look at that thing. That's just incomprehensible. So I'm going to make a change here in my preferences. I kind of asked somebody to do this, but apparently
that's the wrong preferences.
Thank you. Where's the rest of the local variables? Other. There we go. This one here.
Not sure exactly what you're complaining about, but
I'm complaining about my inability. How do I make this more white?
trying to get closer to the center.
Help. Why is it spinning itself? Oh, don't tell me this isn't going to work.
It has to change the colors for every combination of, for every set of brackets, it has to go and change the colors,
Yeah, I understand. I don't have that many notebooks open. All right.
I'm joking, but.
Okay. All right. This is my. Okay. I'm trying to understand. Okay, there we go. That's a lot better. I was so confused by this 2 levels of green. Although I think that's too bright. Sorry, just 1 second. Why is it beeping? What is it doing? Why is it beeping? Let's ask why the beep. Huh? No, it's just beeping at me.
You know, press OK on why the beep.
I can't. It won't let me do that. The whole system is just beeping.
You've beeped yourself into a corner.
Oh, for God's sake. Andrea, can you please note the time and get this piece of video to the
Yes.
people? Thank you. Wow, this is really weird. I mean, it's got that modal dialogue. Wow, what is going on? I don't know how to make this work. That's super annoying. Well, there we go. Oh my gosh, it doesn't even quit. It's just beeping at me. It's quite something. Oh, it brought up on another screen the colors dialogue.
Oh, and that took over everything.
It took over everything. Wow, but it brought it up on another screen. And now, okay, so Andrea, you also need to say ask, I guess, John Fultz, why is this doing this? Look at this.
Yeah, you should give him an end timestamp so he realizes that it was discovered what was going on.
That particular thing was discovered, but this particular thing of okay, in any case, this
Yeah,
was
we have a number of those so-called pop-ups, which should probably be called hide unders, right? I mean,
very funny. Okay, all right. So now I'm this is really helpful to me to see this different color in the selection, because it's been so confusing to me. Anyway, all right, let me go see where does the take. And oh, this is so much better. All right. Something needs to close there.
After the list, after the close.
Yeah, it's transpose. Yeah. Splatteroo. Okay, so let's take.
You can try wrap this list of ranges into a lazy list explicitly, because I don't know how to overwrite an actual list construction.
It's examining every prime, which might take a while.
No, it's not. You don't have normal, so it's doing something different.
Okay, all right.
Oh wait,
But
that was a much weirder. Well, but look at the error. Maybe try writing it outside of lazy and use lazy range if you just want to try the demo.
oh, I
This
just
was a
said
different
range.
problem.
That was a different problem. I just didn't use lazy range. I should have done.
But didn't you use the lazy wrap around everything? Or no, you didn't?
Yes. Well, I'm confused.
Well, because you don't evaluate it. Lazy list has hold all, so it's this problem.
Wait, why does lazy list have hold all?
Well, because it's an actual head for the lazy list. It has to hold everything.
Okay, so then if I press the ... I don't know.
Can you just say take 10 and then normal?
Yippee. Okay,
Neat.
let's go back through this whole thing. Okay. Why did we think that the lazy wrapper, I thought what we had discussed last time was a lazy wrapper headdress. Is that not what we discussed?
I think we did talk about it. I
It
think
was
there was,
mentioned.
sorry, go ahead.
It was mentioned, but I think the last comment would to actually prevent this, not the headers, but this wrapper.
Right. Well, one of the issues that I think arose with the headdress, which was the argument for sort of the parallelized like behavior. But I think, okay, well, basically the argument was that there's some issues if there are any functions with attributes, but I'm not sure there really are any functions here with attributes. And also, well, yeah, I think if it needed to have attributes and therefore needed to be parallelized, like I think it should do what parallelize actually does, which is only look at the outer level, as opposed to being the kind of replace all kind of thing.
Just lexically scoped. Right?
Yeah, but
Not even scoped. I mean, just only at level 0, right? It just looks at the head of the whole expression. I mean, that's at least what, but at that point you might as well, I mean, the only reason to do that would be if you didn't want to have a bunch of lazy range, lazy blank functions. But I think we're kind of okay with that anyway. So
I think we have
Yeah.
no choice. I think that it's going to be too undefined. We're going to have the same problem as the parallelize. I mean, to be clear, I use parallel table, parallel map all the time. No problem with them. I'm very happy with them, except for the fact that parallel table needs to deal with nested table things, Roman.
Yes, that's not so easy, but
I know it's not so easy.
it's on my table. I mean, to do something like parallelize or lazy wrapper properly, instead of handling all these unevaluated and tightly held expressions, I mean, the better approach would be to parse the content into an AST and then do code transformation on those. And I think now we have the tools to do so.
We do have the tools to turn it into an AST.
Yes.
But
I mean,
I mean,
use the compiler technology just for transforming the input expression, finding the places where I can parallelize or lazy eyes it, and then turn it into an output expression.
Look, the fact is we have some things that are magic and invisible, like sparse arrays are largely invisible, and functions just work on them. And I think that's worked well. I'm skeptical whether this is going to be the same thing. I mean, okay.
Sparse arrays are deeply integrated into actual kernel, right? It's a special type.
Yes, that's correct.
So
That's correct. And I mean, I think, all right, we should get off this. Okay, we basically got two concepts on the table. One is the lazy star functions, and the other is the master lazy function, right?
Hmm.
And
Yeah.
this is clearly safer, but seems painful to have so many lazy star functions, but maybe it's not such a big deal. I think conceptually, okay, so here's the issue. We have two choices. Number one, we can have some number of lazy star functions and some number of things for which there isn't a lazy star, or we can have a single mysterious lazy function that tries to wheel in whatever lazy functions there are. Either way, there's going to be things you don't know, like, oh, I don't remember whether there's a lazy cases or not, or I don't remember whether there's a lazy sequence alignment or not. Okay, but in the case where there's an explicit lazy star function, at least you have a fighting chance of looking that up. Whereas if it's a mysterious, be lazy, be happy type function, then it's much harder to do that. Other people's comments on that.
Okay, yes, one approach, and I think the lazy list data type where generators are here on the screen is a very useful thing, and there is quite a bit of expertise about this. I mean, Leonid has written these things. I've thought about it extensively, and I think we should proceed with coming to a proposal for a Wolfram language binding for any number of different implementations of lazy data structures. And for that, we don't need these multi-computation live stream meetings. We need a smaller, focused, lazy working group that can come up with a proposal for the
Okay, but we've got one implementation, which is Nick's implementation, which we could use as the reference implementation before we worry about, streaming and external files and all that kind of thing. But if we agree that we're going to have a lazy list, these lazy list, lazy tree data structures, we don't fully understand lazy value. Lazy graph seems harder to do. But just lazy list and lazy tree are already highly useful. Lazy graph is presumably what we need for these multi-way system things and so on.
Yeah.
Okay, so if we do that with lazy list, et cetera, we also need some lazy star constructors, right? Am I correct?
Correct.
Yes.
Okay, and conveniently, Nick has already implemented a bunch of these things. So if we just ignore this pure lazy wrapper, which we don't really understand very well, and we just use lazy list, for example. So if I just say lazy list, range of 20 or something, why is it taking so long? What is it doing?
No, lazy list is the data type.
Well, can I do that or not? Well, I just did. That works, right, Nick? Yes or no?
Yes, it works.
Why?
What do you mean why?
Well, okay, range of 20 gives a list, and lazy list.
Yeah,
is
it's
a
like sparse
constructor.
array of range of 20.
Yes, but lazy list of range of infinity probably wouldn't have worked, right?
Yeah, because
Well,
range of
no,
infinity-
because range of infinity.
No, I
But-
mean the starting point is one of those lazy star generators usually.
Right.
Right.
And so
but
probably
lazy list itself is also a constructor.
Yes, I mean on the right hand side it says two lazy list, and that is something we discussed last time. Whether it's kind of the odd one out, but understandable because lazy list is also the name of the data type.
You don't have two sparse array. I argue that there shouldn't be a two lazy list.
I don't think we should do that.
Is there different behavior if you give lazy list an explicit list versus a range?
You don't give it a range.
I assume not, because it doesn't have attributes like that, right?
Right. It's just going to evaluate here.
Thought it was
Yeah.
hold all.
Well, because it's a
Better
single,
not
there's a down value for the single argument for the lazy list. That's it. If
Okay.
you have a single argument, depending on what it evaluates to, it will make a corresponding thing. It's a
Okay,
list
so
related to a list.
If I do, let's actually write some real code here. Okay. So I do lazy range, and then I want to say something like, well, I mean, obviously we can do the select prime q here. Okay, let's just see what this actually does. I'm trying to understand this. Okay, so why does it not have a wrapper that says lazy list outside that?
Well, because it's not, it haven't tried to evaluate even the first one, which is 1. So it kind of delays even checking the first value. So it can't really.
I understand, but doesn't it know the head?
Well, not necessarily.
But lazy
can't
range
have
returns a
even
lazy list, right?
Yeah.
So it knows what it is, and otherwise this wouldn't have worked. I mean,
No, maybe it can be the select. It's the problem of what select is doing.
Okay,
but
this
I mean,
is
you
again-
defined an up value for select for lazy list, right? And so why doesn't this turn into a lazy list of 1, 2, whatever?
Well, that's how it currently works. You just have to delay.
Yeah, I mean, these are the kind of things I think we should discuss. These are implementation details that have.
All right. Okay. Fine. But
impact.
let's. Big picture is it seems like, and we need to stop going back and forth on this and just conclude and move forward. I think what we want to do is we are going to have some number of generators here, which includes some of these more complicated ones like lazy subset. No, it doesn't subset. It's subsets plural, right?
Yes, it's typo there.
Okay, fine. So I mean, like lazy tuples of 0, 1. Now, normally lazy tuples here will be, like let's say this, for example. Well, it isn't implemented apparently.
Yeah, it's not fully implemented.
Okay, but Roman, this is a typical case where we will have a finite but large lazy function, right?
Yes, I mean, and that's one of the main use cases for lazy lists, right?
Yes.
I mean, because remember the big search is about combinators. I mean, that was essentially select of groupings of tuples, right? And so you can avoid all the terabytes of
Let's take a look. Let's take a look at the following question. Okay. So let's say I want to write a piece of code. Let's say I'm saying groupings of I don't know. Well, actually groupings. Okay, there's an interesting point about groupings. So, groupings has, if I say, okay, this PQRST, okay, this groupings, I give it a bunch of variables and I do this, right?
Mm-hmm.
One of the cases here, so I'm just trying to understand what I would do. What is the code I would write? So I'm just going to take a sample piece of code. My sample piece of code is proving functional completeness of NAND. Okay, for which I need to basically I need to have a tuples. How does this work? I need to have tuples of P and Q, comma 2, 3, 4, 5, and those I need to put in here, right? As a sequence of different tuples is. Because I'm trying to understand what is there a lazy nest? I mean, there should be a lazy nest while. Is there a lazy nest while?
Yeah, there is.
Where is it? Oh yeah, nest while, lazy nest. Why is there a lazy nest list? Because unless that has a return, how could it fail to generate its full length?
No,
No.
lazy nest list returns a list
generation.
or lazy list of results, right? I mean, lazy nest while doesn't make sense. Lazy nest while list makes sense.
Why does lazy nest make sense?
Oh, it's going to be just lazy value.
No, lazy nest is not a constructor. It's not a generator for lazy lists, right?
Yeah, so this one doesn't really make sense there.
No, lazy nest list is.
Well, it makes sense for the lazy value, not the list. It generates lazy value.
So that lazy value is probably we should not include in the design of the lazy list.
Yeah, and also I would argue I think lazy values are a whole other discussion. And I sort of am a bit skeptical of how a lazy value is useful other than just hold, right? Because if the only thing you can ever do with it is evaluate it, that's just what hold is.
Right. I mean, in terms of our way of thinking about expression evaluation, time-like, space-like, branch-like, etc., what's happening is that, this time-like thing is held with hold. The lazy concept is there is a big spatial thing, like it's a long list, but we're not seeing all of it. We're just looking through a peephole, so to speak.
Well, no, that's only lazy lists or like lazy. I don't know. I think this distinction, like fundamentally, hold all, the attribute hold all is laziness, right? That is what, if our language was totally pure, if you just made everything hold all, you would have a lazy version of the language.
Yes.
Yeah, you're just missing
in the Haskell sense.
Yeah, you're just missing this Haskell type semantics for this kind of things. It's like if you have a lazy func, which is just some code that you want to evaluate, right? There is no any such functionality for just a hold argument.
What?
It's like if you want to feed this held lazy value to some other functions, it's not going to do with it anything, right? There's no semantics.
Oh, I see.
How to handle it.
So wait, this lazy object, if I run f of a lazy object, does it return another lazy object or does it return f of the lazy object unevaluated?
What would be an example here? So if I say lazy in your sense here.
It only works for functions that I've defined. For example, if you do the map, lazy map, or just a map, some of the functions basically defined how they work on the lazy value, but not all of them.
You've not done the right thing.
It's not
try
lazy
lazy nest. do lazy nest f comma x comma 5 or something.
Why are these
That
taking?
should return a lazy value.
It's a
Why
format.
are these taking so long?
I don't know. I can't reproduce it. Some formatting thing.
You can't reproduce it.
So that's slow on my machine.
Well, because I'm having various kinds of things that are really super slow, like graphics row is super slow on my machine. I wonder whether there's some issue on my machine. Okay. Any case. All right.
Okay, press the, well, first try running f of percent or g of percent for variety. Okay, no, it does. So this really does have the same semantics as hold.
Yeah, but some of the functions, like, they know about it. Like map would know about it because I have a sub value, and like all the lazy list functions, especially because I defined it for it. But so
I understand. So give me an example in this case here. Let's say I did lazy nest list here. Okay.
Well, that's a lazy list. That's a whole.
well,
different-
you can even take your select prime example because it returns a lazy value. You can still map over it, right?
Oh, so you could do something like, could you say lazy nest list and ask for part 4, and that comes back as a lazy object instead of an explicit one?
Yeah, for example, you can use part on lazy list. It will return a lazy value.
Okay.
I see. I'm a little skeptical of that, but okay, I understand it.
All right. Okay, so I want to come to some other things. Okay, so look, on this topic, the basic thing we're planning on here is we don't understand lazy value. I don't understand lazy value. We understand lazy list and lazy tree and so on, and we understand the lazy constructors like lazy range and such like, and lazy tuples and so on. So the current plan would be to try and make a lazy system, subsystem, that is based on those functions. Is that right?
Yeah.
Yeah, I think that would be very useful.
Okay, well let's do it. And okay, now let's keep going, because again, the thing we're trying to get to is all of these multi-way functions. So should we look at lazy traverse?
Yeah, why not? That's the previous find path thing, which is just redesigned. Which is not actually looking for a path explicitly.
Okay, so what is this now?
So now if you have like a nest tree, lazy nest tree, you can try to construct one with your favorite example, like x plus 1 to x. Right? You can traverse this tree.
Okay.
Basically expanding some of the lazy nodes inside of it.
Okay, let's try it. Let's try it. Okay, so let's say lazy nest tree. And now this is now a function, so I'm going to do 2 hash, 1 plus hash. Start with 1, for example, and go. Now, I don't have to say how far I want to go.
Yeah.
I
That's
just say that. Okay, can
Yes,
I put infinity there just to make me feel better?
I'm not sure, maybe. Yeah.
Okay. All right. So now, Ian, how would I take the top few levels on that tree using tree operations?
Root tree.
Okay.
Well, I don't have such 3 functions implemented on the lazy.
Okay. So what do you have implemented?
For example, this traverse, basically it's the only thing that I have for trees.
Okay, fine. But conceptually, lazy tree, like lazy list, will have certain operations that know how to work, how to go inside the lazy list, like select knows how to do that. And I guess I have a question. Presumably, the implementation of those functions has to be different for every function. It needs custom implementation. And presumably, we should be able to use, to what extent can we use compiler technology to know both what functions can be implemented and to implement them?
Well, I think all of the tree's functionality would have to be re-implemented for lazy tree.
But the tree's functionality is all written at top level with compiled code, correct?
Some compiled code for some things, but mostly it's not compiled.
Why?
There's not a data structure for it.
I thought you were using a compiled data structure for trees.
Before 13.1, when we added support for associations and leaves.
But so, wait a minute. So tree didn't get slower in 13.1, did it?
It actually got faster because I basically, by doing everything in top level, didn't have to be constantly serializing and deserializing things.
That's not good news. So the compiler basically was taken out. Is that correct? You were
I still
using it and
use compiled data structures in various places in the code, but most of the functionality, like the core functionality for trees, could itself get a compiled implementation at some point.
I'd imagine the thing to do would be to compile it, but not use a different data structure. Just have just manipulate the actual expressions in compiled code.
Okay,
That's
so
one option. Another
that's-
is we did talk with the compiler group about making a new labeled tree data structure, and I worked on that. Basically,
No,
got
but
stuck.
I mean something. I mean, this is probably off topic for this meeting, but there's a slightly different thing of you can have. Basically, you can have types that are internally represented with expressions, so you never have to serialize or deserialize. But there's still advantages to compiling it because even just doing expression operations in the compiler, it's the same as doing them in kernel C code. It means it doesn't have to go to the evaluator, who's generally faster for a lot of things.
By the way,
But,
I'm
yeah.
continuing to complain about your
Right.
audio, Christopher. There's something wrong with it.
I mean, so the first place to start with compiling trees would be getting a compiled nest tree and a compiled tree fold. Those are both special cases.
But okay, look, separate thing, and I don't know who's project managing the compiler, but this is kind of a disappointment that you've gone backwards from compiling to not using the compiler for this. So that needs to be explored, right? But that's not for this meeting. Okay, for this meeting, Nick is saying he's got lazy traverse, which is a function that doesn't have an analog for non-lazy structures, right?
Right.
Nick, what is its analog for not? What does lazy traverse do?
Well, you have this lazy data structure, and it says it does what it says. It's just traversing the nodes of the tree until some condition is met. Or just doing it indefinitely. But it has like a time constraint. You can search for a pattern, or maybe stop at the particular number of nodes.
Okay, so why do we not have such a function non-lazily in a tree?
Because tree is already constructed full-grown tree.
So what? You could still want to traverse the thing. The fact that it's comparatively fast to do that. Well, whatever. I mean, there could perfectly well be such a function, and it will matter given the traversal order. You get to different places depending on the traversal order, right? Like for example, I could easily have a function that says tree traverse of a tree.
I think the main difference is it doesn't modify the actual tree, right? But the lazy tree, when it's getting traversed, is actually mutated in a way.
What?
Because you expand.
Well, only because it's doing some expansion, but that's its business. I mean, in other words, here, what's going to be returned, presumably, let's say I traverse this and I want to find the first time I get below 10 or something in traversing this tree. See what I'm saying? So what is the basic point of traverse here? What is computation?
So that it returns
What
Can
the
I show
hell is this
U3?
thing again? This is not a function. Where's this? Oh gosh.
Well, this is a property. Okay, this is a bad example with some unnecessary property asked for it. If you just run lazy traverse on a tree, it just returns a tree, which is expanded. So you can just run your lazy traverse without any arguments on your nest tree there with your function.
Okay.
And it will run for like a second. It's the default thing. And it's going to produce a new lazy tree.
Why doesn't this have click to copy here? You know, we should make this thing be a Padlet symbol click to copy. Don't you think?
Yeah.
So that's a thing for the Padlets team.
I can check with that.
Okay, so now I have this, and I say lazy traverse of this lazy tree.
Yeah. I think it's formatting a giant tree.
Well, I don't understand that. How do I tell it to stop more quickly?
Just specify a pattern, like to stop at. For example, 10 is definitely in the tree. So it's gonna stop at 10.
Okay. Although 10 might be in the tree more than once, right?
Yeah.
So
So
which
that's
10
why-
is it stopping at? That's where the traversal order comes in.
Yeah, because it's not just breadth first, depth first, it's also deterministic versus deterministic traversal. So if you have like a 10 appears once and it's a deterministic, it's not gonna go inside of it if it finds another 10.
Right. Okay. So we can think of this as a way of making a multi-way system, except for the fact we don't have any equivalences here. Right?
Well, it's the same Q equivalent. If it's a deterministic traversal and it's another same 10.
Oh, but this is a tree. It will be a graph if it had actual equivalences.
Oh yeah, I think that's when the next function in the agenda is useful for how you generate
The
edges
or-
from this tree. Yeah.
No, but
basically.
look, what I want, as we know, what we're trying to do is replace the multi-way functions, right? So is that okay? So is this what this does? So if I use multi-way nest,
Yeah,
is that right?
Is almost the nest tree. So it's basically
Okay, so but if I can say multi-way nest of my favorite function here. So if I say multi-way nest of this,
it doesn't take a third argument, so just ignore it.
Does not take a third argument. Okay.
Yeah.
All right. So now I don't understand why that's a lazy list. I don't think it's a lazy list. It's a lazy graph, isn't it? Or if it's anything.
Well, it's the same thing, just because you can have more than one initial condition. That's the only difference now. That's why I have a list of trees.
Okay. Okay. I don't understand why it's trees. They shouldn't be trees. It's a frigging graph.
Well, you can. I don't know what to return on this point. It's just a data structure that you can traverse or extract edges from.
All right. So draw the multi-way graph for this, please. 5 levels of multi-way graph. How do I do it?
So you say lazy 3 edges on that.
Okay. Of this thing here.
Yeah.
That seems like the wrong function, but go ahead. What then what?
And it should produce it. Well, that's it. Okay.
No, how can it be it? Okay.
Well, we don't have a way to specify levels.
Okay, but we need
I
that.
can do that.
That's what we need. That's what we need.
That's an additional.
Okay, so how do I get the first few levels here?
You just use take. Well, it's not gonna levels, but for now, imagine that it's levels and normal. You can extract edges because it's an edges thing.
That's not what I wanted. I wanted a graph.
But that's for the future. I don't know how to.
Okay, but that's the point.
You
That's
turn
the,
it
that's
into
the
a
thing. That's the point I was making, right? So let's say we say 10 of those, and we say normal, and now I say make
That's
it,
an intermediate point. So imagine you have a lazy list of edges. Now you have additional lazy graph around it that handles it. I can like make it.
yeah, okay. So you're saying that what will come back by default here from this multi-way nest. That's weird. Is a collection of disembodied edges. Is that correct?
One of the things you can ask for, but
Well, what are the other things you can ask for?
well, like you said, if you want layers, it can be layered numbers of edges.
No, but the basic thing you're returning is edges, correct? And it's a bucket of edges, and which edges you get depends on how you foliate the thing and so on, right?
Yeah, on your traversal order, depends on traversal.
Well, yeah, right, which is the same. But so what you're claiming is, which is, I don't know how this agrees with what Ian is doing with trace graph and so on. What you've got here in multi-way nest is that the fundamental structure that you're returning from multi-way nest is a collection of relations, of before-after relations. Am I making sense?
Well, if it's the same as returning trees, then yeah.
No. Look. What you've got here. Okay, you're saying multi-way nest is really a tree.
Yep.
By asking for tree edges, which that is a function, right, Ian? There's a tree edges function normally for a tree. Is that correct?
No, trees don't have edges.
So what the hell are we doing here? How would you describe these things?
You could do edge list of a tree, and what it does is it converts the tree to a graph where you lose information. But there's no
Okay,
correspondence.
so Nick,
between
I don't
tree and
understand
graph.
then. Is it a tree with payloads or is it not a tree?
It is a tree, but you can extract all the edges. You can turn
But
it.
there
into
aren't edges in a tree. But
you can
Ian
construct
was
them.
yes, I know, but then you lose information, as Ian just said. You lose the information about what's at the nodes in the tree, right? Because what you have, in order to make an edge, you have to use the canonical ID of each tree node, not its payload, because payload may not be unique.
Right,
Actually,
that's
what
one.
you're doing is you're cheating here because you are using the payload because that's how you're merging in this case, right? You're just using the payload information.
That's
So
right.
your tree edges are, oh my gosh, what a mess.
Yeah.
And you
Like
can
even without
label-
the equivalencing of that you were mentioning of joining things, there's an automatic equivalencing of distinct nodes with the same payload.
Exactly, but in a tree, there isn't any of that, right? A tree,
Right.
every node is distinct,
Yeah.
right? Okay, so a question for Ian would be, can we peel off from a tree? I mean, I don't know whether this is a useful operation, but how would we go? Let's imagine that we do, okay, so let's say, how do we make a random tree? Let me do this. Let's say I make a random tree, 20 nodes, and now I want to put on this tree, I would think it will be tree map of, let's say, random integer 10, if I'm not mistaken, onto that tree. Does that do something sensible? So that, right. So that is causing some of what's painted on those nodes to be distinct, to be not distinct, right? Right. So now what I want to do is I want to graphify this now not non-distinct. How do I make this into its corresponding equivalence?
Tree graph.
What's that? Tree graph.
Yeah.
Wasn't that exciting, but let's do this. Let me just do this one here. Random tree 20. Now this, let's just do 5 or something here. Okay.
It's not equivalence, and that's the point.
Yeah, that's not right. It's not correct. That's not what I want. I want to actually do the equivalencing here. You see what I'm saying? Using payload data.
Now I think you'll have to do like a vertex replace.
Okay, but so I lost.
Look at the vertex list of that graph.
Yeah, I'm sure it's got tree-like vertices.
It's a payload and with its position.
Right. So that's not right. So how do I get the thing I'm asking for, which is this tree equivalenced into a multi-way graph? If Nick is selling this idea,
there's certainly no built-in in the trees project to do that.
Okay, but what Nick is saying here, which is muddled in my opinion, is we've got something where it's fundamentally a tree, but then he's peeling off these things that he's calling tree edges, which don't make any sense because trees don't have those kinds of equivalenced edges. But what we need is something which extracts the graph. Okay, if it is true that our fundamental structure, and I'm beginning to think that this is sort of the way the universe works, sadly, that every atom of space is distinct, so to speak. Every atom of existence is distinct, and all of the equivalencing into a multi-way graph is all a matter of the observer. But so I'm not necessarily that opposed to this idea, so long as it can be done efficiently, of the fact that the concept that multi-way nest is fundamentally making a tree. Nick, did that make any sense to you?
Well, somewhat. So you can imagine that tree edges also have an equivalence function built in. Right? It
Yeah,
can
but I don't
take-
think tree edges is not the right name, right? So because what we're trying to do here is
okay.
right. And,
Yeah, we can think of
this
better name.
atomization, I understand that, but the concept that we represent what is essentially a graph by this atomized list of edges is questionable to me. And I don't see why we're not just using the graph data structure. Do you see what I'm saying? So given a multi-way nest, to have something that's called like multi-way graph that simply takes from a multi-way nest and makes the corresponding graph.
No, yeah, that's what lazy graph.
It's not right. Go ahead. What? Yeah.
It's like that's what lazy graph wrapper can do. It's like just it has a multi-way nest tree inside of it, which just takes edges one by one to construct like.
No, this is not a general lazy graph, so we shouldn't call it lazy graph. It's a
That
very
would be-
specific lazy graph that goes from a tree to generate a graph, right?
Okay, what other kind of lazy graph you have in mind?
I don't know.
When you have
It's
like
not,
a lazy
not necessarily
adjacency,
coming from a tree. It's
or you
not
can make a
necessarily
lazy
coming from a tree.
adjacency matrix, for example.
Yes, you could have all kinds of lazy graphs that have all kinds of fronts that have, a front where there's activity going on. It's not necessarily a tree.
Oh, sure, well, but the tree is one
But
of
we
the.
shouldn't call it lazy graph. I mean, okay, look, okay, let's zoom out again, right? Because we really need to actually get the okay. So multi-way nest probably has the wrong name if it's generating a tree.
Yeah, just a nest tree. That's a shortcut for nest tree.
So what is it? Is it nest tree? Is
It's
it
the same-
basically a lazy nest tree?
Maybe nest trees because the only difference is just multiple initial conditions.
It's like a lazy forest.
Yeah.
It's forest is almost like a tree, it's just missing. Forest is a tree without a payload. You can. Right?
Wait, what are you saying? No, that's not right. It's also a multi-rooted tree, right?
Yeah, it's
Forest is multiple trees.
Mm-hmm.
Right?
You can put them as a children of one single node that just doesn't exist, and you just made a single tree.
Yeah.
Right?
Yes, I understand. It's the Big Bang. It's the the creator of everything. Okay. So okay, let's go back again. Right? Okay, remember what we're trying to do. We're trying to replace the multi-way functions. Have we succeeded in doing that here? Or have we made something completely different? What have we succeeded in doing?
We're trying to succeed at making some kind of unified thing
Right.
to process
Right.
things.
So, okay. So let's walk through what we've actually done here. Okay. So what you've got, multi-way nest. Okay.
It's like my current claim is that everything that produces a multi-way graph underneath
Underneath should be a
it
tree.
Yeah.
Should be a
That-
lazy tree.
Yeah.
It's not an obviously silly claim. Okay, so long as we actually have functions that produce what we need. Okay, so let's walk through what we actually get here. Okay, so what you've said is you've got a, wait a minute, is it lazy nest tree or is it multi-way nest? Which is it? Can we
Well,
decide which is it?
It depends.
No,
It's-
it doesn't
it's
depend.
no
It's gotta be
use.
what is it? Go ahead.
If you want to mimic the nest tree functionality, then it just takes a single thing and produces a tree.
Okay,
Multi-way,
so the only difference is multiple initial conditions. Is that correct?
yeah, and multi-way nest maybe have some additional properties. that
Whoa,
we can-
whoa. No. I'm trying to understand this. What is it? Is it the same as lazy nest tree with multiple initial conditions or something different?
Well, if we agree on the lazy graph, then it should produce a lazy graph thing. And what
No,
it's
what
doing
should-
eternally doesn't matter. The multi-way nest thing.
we've been talking about lazy graphs for like 3 months. I think lazy graphs are really difficult because I think this evaluation front thing, we do not have a good way to think about that.
Well, we can do if you have a lazy list of edges, then a lazy graph with fronts is just a list of edges, just a nested thing. You just have each layer explicitly there, and if you catenate it, you get a graph. Just a simple list of edges.
Okay, let me go through a different thing. Remember, and I hope you've been keeping this in mind, multi-way system has all kinds of crazy options. For example, it has an option that it has all these unification options, right? For uniquifying by layer, uniquifying by node, et cetera, et cetera, et cetera. Those, I think, have to do with when you conflate the elements of the tree, when you actually make the equivalence between the 0 here and the 0 here, and so on. Am I making sense?
Yeah, you still have a tree, but you also provide it with the equivalence function on top of that instead of a same queue.
Yes. Yes, but the equivalence function might depend on, tree position, for example. Am I making sense?
Yeah.
Because that's what the foliations, you might equivalence. Yes, I mean, okay, fine. All right, so do you have an equivalence function in these things that you've built here?
Well, I don't have it, but implementing it's not a big deal, I think. Because I
Okay,
do
let's
compare
walk
them.
through it again. Let's walk through again what we're doing here. So we've got this idea, if we have multi-way nest. Okay, first of all, this is just not going to work to return something wherever it was, to return this lazy list of lazy tree of whatever. It's not going to work. Let's not do that, right? We've got to have a definite structure. We've talked about this for months, right? A definite structure returned by multi-way functions that doesn't spill out random pieces of trees and, and lists and so on. Does that make sense? It's got to be an opaque
For
object.
multi-way functions, sure. It's just I find it useful if there is some.
We're
other
not going to
kind of
have it,
function.
though. We're not going to have it because it's super confusing, right? The fact that it's implemented that way is irrelevant to the user of the function.
No, but I mean, if you have a thing that the user produced a lazy tree with some different way, and I want to traverse it and maybe even produce a list of edges, why not?
But no, look, okay. We are agreeing we're having a fixed set of structures, lazy list, lazy tree. Those are the ones we know we're having, right? Those are the structures that we're supporting with these lazy, in a lazy way. Does that make sense? Do we agree
Yeah.
on that?
Yeah.
And nothing else. Those are the only two.
Well, I'm not proposing a new one. It's just a lazy list again, but with the edges.
But that's not what it is. It's not what it's going to be. because that's a disembodied structure, not something that came from a multi-way graph. We don't want that. We don't want to just spill out
Yeah.
a list of edges. That's why a graph is not represented in our system as a list of edges. It's represented as a graph. Same thing here. Does that make sense? Let's not go back on this again. We've been, we've had too many meetings where we don't, we got actual conclusions here. We get rid of this. We're not having it right now. We've got lazy list. We've got lazy tree, right? We're not having lazy value right now, right? We don't need it. We're not going to have it. Do you agree?
I don't know.
Look, we got to have an actual design that we can agree on that people can use, not a design that has all kinds of random tentacles hanging out that keep on changing from week to week. Right? We can have a bunch of tentacles that are separately done, but we've got to have a fixed set of things that are what we agree on, what we implement, what we document, what we build up, we make sure work in all cases. Right? Because right now we're just not reliable enough. I mean, we've got to have a fixed small set of things that we really build up. Does that make sense?
No, what can we do with that small set?
The things we're trying to do. We're trying to, the functionality we're trying to get, which does not include this lazy value functionality, which we don't understand very well yet.
Well, it's very essential for actual implementation of those functions. So I'm not sure how to get rid of it completely.
Why is it essential for the, okay, can somebody else explain to me, why is it essential for the implementation of those functions?
If you want a lazy list, if you want to, like, if you have a lazy nest and if you don't select and you don't know where to stop, when maybe if it's not even, if you're selecting from...
Yeah, that's some internal implementation detail. It doesn't matter to the user. The user never needs to see that. So don't show it to them. Right? It's an internal function.
Like in that example, if you just have a part extracted from a lazy list, what should be returned then?
It should probably return a concrete thing. It should return the same thing as what you do right now for normal part.
But it's
well, what Nick is saying is he wants to have a thing. This is what he keeps on saying. He wants to have a thing that is basically hold. That when you say
right, but I think part should not return hold, if you know what I mean. Like I think it's okay. Like basically the point is you have lazy objects. There's certain ways that you can ask them to actually evaluate, right? The most explicit one is normal. But I think also part extraction is another legitimate one that should make it, unlazify itself. I mean, if you think about, we can draw analogies. I mean, certainly the other kind of various, Mathematica lazy implementations, I think usually do this. Like I think the streaming stuff does this. In other languages, like with iterators or with generators and things like that, usually indexing is like a eager operation. I think it's a reasonable thing to do. And realistically, there's nothing that you might want to do. If you do a part and you get back some held or lazy thing, there's nothing to do with it other than to release hold it. Otherwise, why'd you even ask for it?
Well, it's not necessarily the case. If you have a list of lazy values, you can use dynamic programming, for example, to extract only to release only necessary parts of it.
Well, but if you have a list of lazy things, hopefully you got that as a lazy list. I mean, if you wrote your code in a way so that you happen to not come out as a lazy list, it came out as a list of lazy parameters.
Guys. But by the time we have lazy value, right, we have a whole pile of crap here. Right, every single thing in the system then has to be, we've got a lazy version of every single thing in the system. This is not going to work. It's never going to be implemented correctly. It's never going to work unless what lazy value is basically just hold. So we shouldn't be going down that path. We are trying to get a specific set of things, set up lazily, like lazy tuples, lazy subsets, etc. Not every possible expression, because every possible expression is not implementable, except in a trivial way. Am I wrong?
Why are we talking lazy, any possible expression?
Because
Lazy
that's
value
what
also
lazy
means
value will return. It can contain any possible expression. I can put any function I want in there.
Oh, sure, but it also can return a lazy list again.
No, but the whole point is, look, what we're saying is we have a fixed set of lazy structures, lazy list, lazy tree. That's it. Anything else, any function that doesn't work with those, doesn't work with lazy things right now. Just comes back as f of the lazy list. Right? Doesn't try and pretend that it's doing something with lazy value where it encrusts things in lazy value and then everybody gets confused. It just says, I don't do it right now. Just like sparse array. If you say f of sparse array, it just comes back f of sparse array. It doesn't try and wrap sparse array around the f and confuse everybody. See what I'm saying? Is there a reason not to do that? In other words, there's a fixed set of lazy objects that have certain functions that work with them. Every other function just stays unevaluated. Is there a problem with that?
Potentially. I can't pinpoint it right now, but I think there is a problem.
Okay, well, I'm going to claim that there isn't a problem. I'm going to claim we need to make sure there isn't a problem because the other way of doing it isn't going to work. So, maybe there's a third way of doing it, but this way of doing it isn't going to work. It's just going to lead to confusion and everybody being unhappy. So let's come back to what we were trying to do over here. Okay?
Okay.
All right. Let's be very, we have a multi-way nest and it returns some kind of, I thought it was supposed to return some kind of computation object. That's what we said like months and months ago, but that's apparently never happened. What does it return right now?
This lazy forest thing.
Okay, are we going to have a lazy forest? We're going to have
Oh,
such.
we don't
I
have
don't
it.
think we
We don't
need
have
it.
to do it. It's just a list of trees.
Okay, a finite list of trees. Finite list of lazy trees or what?
No, it doesn't have to be a finite. It can be an infinite in both directions, in depth or in length.
Okay, fine. So what is the actual object that we are going to return from multi-way nest? What is it going to be called?
Or if you want lazy, some kind of computation object.
Well, is that the right thing? Because that, again,
I don't necessarily agree with it. It's like I like just a thing representing this list of trees, or just a tree or a list that just doesn't come from the multi-way kind of function, but from other kind of functions. For example, I have a function lazy directory, file directory, right? If you want to just traverse this kind of thing, does it make sense to wrap it with kind of multi-way related object? No,
no, it doesn't.
it's just a list of trees that with payloads representing directories and files. And you want to call the same traverse function too.
Reasonable enough. All right. But then, okay, so, okay, how do we reproduce the multi-way system functionality given the output from multi-way nest? What is all that crud? Okay, whatever.
Basically, the computation code.
Okay. So we've got this thing. Here it is. Okay. I hate the way this looks, but that's okay. All right. Clearly, we can clean up the appearance of it.
Yeah.
Okay. Now what do we do? Now, let's say I want to take, let's go to the multi-way system page. Let's say I want to generate the first 3 levels of this. I want to generate the numbers on the first 3 levels of this. How do I do it?
The actual numbers.
The actual numbers, yes, the actual numbers. So if I were to do the following thing, if I was to say, if I were to say,
There's some kind of tree function that does it for trees, right? So that would be the same thing. Or the
Well, but
function that,
root tree isn't going to support list of trees, or should it?
I don't know. That's the thing we have to discuss.
Yeah, it's like what's the actual difference?
I mean, so does multi-way
That's what I
nest
wanna get.
support an
That's what-
association?
What association?
Here.
Well, so nest tree supports association list
Yes,
and none,
it
and
should-
also
it
supports
should- it
hold and
should do
hold
that.
complete.
Look, it should
Or
support
is this
multi-way
Is
nest.
this supposed to be a graph thing?
No, multi-way nest should support an association here because that will tag edges. We know that. That's different types of events are needed that will tag edges, right? Does it already do that or not?
It's a yeah, kind of, but it's not an association. You have to label each of the outputs.
I don't think that's right. Because it's got to be the same way it works that it works in trees, which is to use associations to make labeling. Your objection was that the labels might
Oh,
be
so-
not have two identical labels.
Yeah.
In trees, it creates associations of children. It doesn't create labels for edges because there aren't edges to label.
Okay, but here, if we're generating token event graphs, for example, we need a mechanism to do that. So look, I'm looking for how do I get this out of this? See what I'm saying? How do I get this type of thing out of this?
Well, the closest thing is that three edges thing. You just have to only extract the target from each edge.
That's a total mess. Right, so this is what we need to work through, right? This is what I've been saying for months, right? We've got multi-way system. We know what functionality it has. We need a clean way to get that functionality from this other approach, right? Which doesn't mean, you work through, you take parts of this and that and the other, right?
Yeah. Well, three edges is basically prototype for this kind of traversals. Right now it produces edges, but it's the same traversal, but instead of edges, it just produces targets, and that's gonna produce the same output you want.
What is it? What was it called again?
It lazy three edges.
Because it's producing a lazy list.
Yes. And internally, I have a function that produces a list of lists, and that would be correspond to this kind of layers that you have above.
Okay, but so then in lazy tree, wait a minute, lazy tree edges is not lazy traverse, which is yet a different thing.
Yeah.
Lazy traverse is essentially selecting a piece of a tree. Is that correct?
It's not selecting it; it's expanding it. It's the same tree, but some of the nodes expanded.
What do you mean by expanded?
Well, the
You mean
actual
non-lazified.
yeah, unlazified, evaluated.
Okay, why does it exist? Why does it exist? Why are we not just saying, tag the tree and then use normal to get the result?
Well, because it's infinite. How do you say to what point to relate it with normal?
No, I'm saying lazy traverse apparently actually return. What the hell is this again? What is this? What is this?
It's a property. It's a bad example, as I said. It asks for a computation property there.
I understand. So what should this do?
It makes a lazy tree again, which is partly evaluated. You have your multi-way nest on nest tree. You traverse it, and you get a new tree.
Let's get rid of this. What other property can we ask for? So I just say traversal order.
Just don't ask any property. It's gonna produce a new tree.
Okay. So that's the breadth first traversal order. Now, and then how do I make? So then, with that, okay. So then, if I say your lazy tree edges on this, you're saying I will get the edges in breadth first order. Is that correct? What is it doing?
No, it takes this. It takes the method also. It takes a method how to traverse it.
No, but it just had a traversal order. It's got a traversal order.
No, this option is gone. You have a tree which is just partially evaluated. You don't know how it was traversed.
Okay, so what you're saying here is that what does that 10 mean?
It's the target when to stop your traversal. So as soon as the 10 is found there,
Okay, that's not a good design, right? Because what you're saying is one thing to do is go X number of steps in a.
Steven, can you open the ref page for beam search?
It's not a real ref page. It's in
The
document.
source web page, yeah.
I'm sorry, the source.
Two documents. Yeah. So this was a design, I think, from the machine learning people, and there's different notions of how you end things, like max iterations, end of sequence token.
Yeah, which need to be cleaned up. But yes, this is okay. So this is certainly related.
Yeah, that's a very close design.
And this node visitor function should the design should probably be aligned with what we're
node
doing.
visitor function?
Nest.
What node
Like
visitor? Oh
nest
God,
tree.
this horrifying thing.
Yeah.
What is this? Node visitor. What does this mean?
It's a way of doing nest tree.
But so look, beam search. What does beam search return? The path or what?
I'm not sure.
I don't
There's
remember
multiple
that.
things you could have it
I
return.
know.
We'll talk about
It's the same thing as find
Yeah.
replace path, which I wish I'd finished, just put in my implementation of this like a year ago, right? There are like three things it can return. It can return the path, it can return the subgraph, it can return the thing it found. I mean, just like, we have cases, we have position, we have count. It's not, there can be multiple functions, a limited number of functions that return different kinds of things you might want to return. And that's, I think, what we should do here, rather than having all kinds of weird properties. I think we should figure out what the small number of things you might want to return are, and then have functions that do that. But what's going on here is, okay, so again, I don't understand. Okay, why doesn't lazy tree edges have a traversal order?
It has an additional one. It's a method though, because it also can be deterministic and not deterministic.
So what do you mean deterministic? It's still got a traversal order. It's still going to return the tree edges in a certain order, right?
Yeah, but it can visit the same node twice or no. Deterministic means whether it visited the same node again or not. Well, that's infinite, right? So stop it. Abort.
It's not infinite. You just said go to 10 here.
But the lazy tree is still the same lazy tree. It still contains the computation how to go.
Wait.
It takes an infinite tree and it produces an infinite tree where parts have been computed.
Yes.
Oh, that's not the right thing to do. That's just not the right thing to do.
Well, you can turn this into actual tree. I have a function for that.
Yes.
If you have a partially evaluated lazy tree, you can turn it into actual tree. But it's still, the lazy tree is still infinite. So like you can take this.
Okay, but I don't care about this function. I mean, look, the whole point about laziness is you only compute when you need to find an answer. So this function is either finding an answer, in which case it's computing and returning the answer, or it's not finding an answer, in which case there's nothing for it to do.
Well, that's
this idea that you're rejiggering the cache is not something that these functions should be doing. I mean, rejiggering the cache is a separate behind-the-scenes activity, because that's all this is doing. Is that correct? Is rejiggering the cache? Is that true?
I don't know what do you mean by that.
But what I mean by that is the actual semantics of the structure that is there is, in this setup, not changing. The only thing that's changed is you have explicified some part of the lazy structure, correct? Which is purely a cache.
Sure.
The actual structure does not, if I asked for the 11th, if I asked for some other element here, it could compute that perfectly well because it's got the complete lazy structure is there. Right?
Yeah.
So it's just not the right thing to have a function. I don't know why we even have a function that just rejiggers the cache. In other words, it's either let's return to me the tree that I get by going to, find 10, or let's just have the original lazy tree. You see what I'm saying?
Well, that's why this traverse function have a bunch of properties. One of them can be an actual tree.
Okay, but we shouldn't have the function that just does, okay, the recaching function is a very corner case, weird optimization function. It's not the relevant function. I mean, what it should do is return the frigging tree. The actual tree just stopping at 10. Right? That's what it should be returning, not the infinite tree cached to 10. Am I making sense? There's no reason to ever do this to get an infinite tree back. You should get the thing returned to 10, so to speak. Now, it could be the case that the thing will choose, I don't know. There should perhaps be a way to get this recached data structure, but that's not the primary function. The primary function, without asking for any other properties, should return the actual tree. Does that make sense?
Yeah, but maybe that shouldn't be called traverse then, because if you're traversing it.
No, I don't think it should be called traverse. I think it's a super confusing name.
Yeah, but this one I find useful. It's just a jiggling of cache.
Okay, but fine, but that's a largely internal function.
Oh, if you say so, okay.
I mean, I just don't think it's very useful to users. Maybe it will be, but I don't think that's what the primary thing we should be talking about. Okay, look. Okay, I'm going to have to go in a few minutes here, unfortunately. And I want to, okay, multi-way replace. Is that now implemented as we talked about last time? So there's an alternative here that I could say, instead of saying where it was, multi-way nest up here, right, that I could as well here say.
Yeah, I think multi-way replace works with this new pattern matching, but it produces the same kind of thing. So.
Okay, I understand, but multi-way replace would say,
list of
we're going
rules.
to take an integer, I is an integer, and it goes to 2i, I plus 1, and it starts from 1 and does the same thing, right?
Yeah, it should.
Okay. And multi-way evaluate is based on colon equals rules. Is that correct?
Well, all the values, potentially.
Yeah, okay, fine. But so multi-way evaluate should allow us to give the multi-way version of Ian's trace graph. Is that correct? Multi-way evaluate should generate a structure which can give us the multi-way version of trace graph. Is that true?
Oh yeah, it will produce the same kind of thing, but also labeled with positions and maybe bindings.
Okay, but that's fine. But we're trying to actually get a result here, right? So we haven't quite finished the design of trace graph and the thing that is representing an evaluation graph. But this should be a multi-way evaluation graph. You should be able to extract from this a multi-way evaluation graph. Is that correct?
Correct. It's just what 3 edges is extracting, essentially.
Okay. Well, we should see an explicit version of that. But okay. So just so I understand here, in multi-way replace, if I want to make a token event graph with, how would I do that? A tuples-based or a subsets-based token event graph. How would I do that?
Well, you write a similar traversal to 3 edges, and just, or maybe even use the edges itself to just turn every tag into an event. Something like that.
No. I'm talking about multi-way replace. I'm talking about, should I be using, for example, if I have an event that takes an I and a j, right? And then I produce, let's say, I plus j, I minus j.
Well, that's subset replace. It's a little bit different, right?
Okay, I guess it is, yes. So I guess we need then multi-way subset replace. Is that correct?
Yeah. We have it there in the guide.
So then if I use it here,
Well,
Is
it's not implemented, but it can-
okay, but conceptually, this is how it would
Yeah.
work.
Yep.
Okay, that makes sense. And what is a multi-way tuples is the version of this where you can have any number of copies of an element. Is that correct?
Correct. And maybe all order tuples too.
I wonder whether that should be part of subset replace, whether those should be options to subset replace, whether to allow, I mean, it's kind of like an overlaps arrow, true or false for subset replace.
Maybe. Or maybe it should have a completely different name. Maybe it's an expression replace.
What?
If you want multiple parts of an expression be matched against.
Well, okay, unfortunately, I have to disappear in a moment. Okay, I think we're going to need a separate meeting, Nick, at some point here about this. I mean, do you feel like this is, I mean, we're making progress here, but it's a little bit painful that it seems like we keep on, and Nick, you are coming up with a bunch of pretty good unifying ideas, except that I'm just concerned that the animals keeps on growing more tentacles. And you know what we're trying to do here is put the thing in a box without a lot of tentacles hanging out and make sure that we can actually implement a definite thing that people can understand.
Well, if you want to reach with those tentacles to the multi-way functionality, then it's got to be more. Sure.
Okay, yes, but my claim is, okay, the whole point is the multi-way functionality. I mean, I'll give you an example, but okay. I think I need to go, unfortunately. All right, to be continued. I mean, anybody else want to make any last comments here? Ian, Roman. Okay. All right. Okay. I have to run. Thanks a lot, everybody. See you all soon.